Hi students, in this lecture I am going to discuss problems on wave motion. Let us see what is given question here. A string of length L fixed at both ends vibrates in the fundamental mode at a frequency f and a maximum amplitude A. Find the wavelength and wave number. Take the origin at one end of the string and the x-axis along the string. Take the y-axis along the direction of the displacement. Take t equal to 0 at the instant when the middle point of the string passes through its mean position and going towards the positive y direction. Write the equation describing the standing wave. So this is a question given. Let us see how to solve this one. So amplitude is A, frequency F, both ends fixed, length is L. And we are taking string is along x-axis and oscillations along y-axis. Right, and here if you see the key points here, take t equal to 0 at the instant when middle point of the string passes through its mean position. Middle point. You can see here, it vibrates in the fundamental mode, right? That means there is only one loop, right? So one loop means here midpoint corresponds to antinode. So antinode of the string passes through its mean position and is going towards a positive y direction, right? Okay, see how to solve this one. Right. So first see what is given here. It is a string. It is a string. Right. Okay. It is a string given fixing both ends. String both ends fixed. And you are given string length equal to L. So take x equal to 0 this end and x equal to L other end. And condition given that it is first harmonic, right? Fundamental mode means first harmonic, means only one loop. Only one loop, right? And condition given that when t equal to 0, according to given condition, string shape will be straight line. This is the condition given t equal to 0. T equal to 0, midpoint is passing through mean position. That means string is straight line. So when string is a straight line, see what we can write here. And we have taken string is along x-axis and oscillations along y-axis. That is what given here. An equation y equal to amplitude is A, that is given A. Here you can see x equal to 0. It is a fixed point. So this point cannot vibrate. So this point cannot vibrate means that is a node. So for node displacement always 0. Therefore, when we take kx, it must be sine function. So kx must be sine function, sine kx. Because x equal to 0, sine kx becomes 0. Okay. Right. Next, coming to omega t. Omega t, what we have to write? Is it a sine omega t or cos omega t? This is what we have to focus. And for that, we are given midpoint. Midpoint is passing through mean position and towards positive direction, along positive y direction, right? So passing through mean position means for antinode, displacement equal to 0 when t equal to 0. I am repeating, for antinode at t equal to 0, displacement is 0. And this is a possible if we write omega t also sine function. So it is now sine omega t. Okay. Because if you take t0 here, what is y value? It is 0. Okay. Na? The importance of giving midpoint passes through mean position. Okay. Suppose question is given like this. At t equal to 0, midpoint of the string passing through or midpoint of string is at its extreme position. That means its string shape will be like this. Midpoint of the string is at its extreme position. This is when t equal to 0. We can see this equation is for this diagram. Okay. Now, if question is given like this, midpoint of the string is at its extreme position, then see what happens here. Coming to sin kx, no change. Y equal to a sin kx. So why no change means? Because x equal to 0 is now fixed. That is a node. Okay. But coming to here for anti-node, now displacement is a maximum when t equal to 0. Therefore, we should write here cos omega t. So when t0, cos omega t becomes maximum. Therefore, y value will be maximum, right? Because condition given, midpoint of the string is at its extreme position. So it depends on the given problem, right? Is it like cos omega t or sin omega t? So whenever both ends are fixed, it must be sin kx, that is a fixed. Okay, that we cannot change. The only thing remaining one is sin omega t or cos omega t. If antinode is at mean position, if antinode is at mean position, write sin omega t. If antinode is at extreme position, write cos omega t. Okay, right. Now go for next problem. Let's see next one. A 2 meters long string fixed at both ends is set into vibrations in its first overtone. The average speed on the string is 200 meter per second and the amplitude is 0.5 centimeter. Find the wavelength and frequency. Right? Write the equation giving the displacement of different points as a function of time. Choose x-axis along the string with origin at one end and t equal to 0 at the instant when the point x equal to 50 has reached its maximum displacement. Right? Now see carefully here the key points in this one. String length is given fixed at both ends. Okay. So we should write sin kx. Right? Both ends fixed. Next. Vibrates in its first overtone. First overtone means second harmonic. Right? That means having two loops. Having two loops. That means length will be two loops means it is a 2 into lambda by 2. 2 into lambda by 2 equal to 2. So lambda value 2. So we got lambda, right? Wavelength. Frequency. V equal to F into lambda, right? V is given. We got lambda value 2. Then we can find frequency. Okay, see next problem. Write equation giving the displacement of different points as a function of time. Choose the x-axis along the string with the origin at one end and t equal to 0 at the instant when point x equal to 50 centimeter has reached its maximum displacement. Students, you have to focus here x equal to 50. So this is a corresponding to antinode. Antinode is at its maximum displacement. Okay, right. See how we solve this problem. So first condition, we are given speed equal to 200 meter per second. 200 meter per second. Next, we got lambda, right? Lambda we got 2 meter because it is given that two loops. I will draw a diagram here. Given first overtone, let us take x equal to 0 and x equal to L. X equal to L. It is given second overtone is two loops, right? Two loops means what I can draw diagram is now. Diagram is like this. Okay. Actually, loops size must be same. Right. So two loops means what I can do is here L equal to 2 into lambda by 2. L equal to 2 into lambda by 2, right? Because node to node separation lambda by 2. So this also lambda by 2, 2 lambda by 2. And you are given L value 2 meter. Therefore, lambda value 2. Okay, right. So we got lambda. From lambda, we can calculate F value. F equal to V by lambda. Therefore, V value 200, lambda value 2. So F is 100 Hz. That is frequency. Right. Now he's asking, we should write equation for displacement. This is x and oscillations along y-axis. So see carefully what we have to write. Since x equal to 0 is a fixed, we have to write y equal to, if amplitude is a sine kx, this is a fixed. Okay. Coming to the remaining one, omega t. Is it a cos omega t or sin omega t? Right. Now see carefully, x equal to 50. X equal to, I will show here different by taking different color. Right. You can see here, this is now x equal to 50. Right. Because this is x equal to 100. X equal to 100 centimeter. And this is x equal to 50. Okay. So that is a corresponding to antinode. Now antinode is at its extreme position. That means when t equal to 0, its displacement is maximum. That's why we have to write here cos omega t. So when t equal to 0, y value will be maximum, right? Because for antinode, sin kx becomes 1. Okay. So kx, why sin kx means because x equal to 0 is fixed. Why cos omega t? Because antinode is at its extreme position when t equal to 0. Right? So this is now equation for displacement as a function of position and time. Now in the place of k, you can write k value 2 pi by lambda and omega value 2 pi f. Okay, then we get the value of pi, right? Let us see next problem. And this question also taken from H.C. Verma. Let's see what is given. A 2 meters long rope having a mass of 50 gram is fixed at one end and is tied to a light string at the other end. The tension in the string is 256 Newton. Find the frequencies of the fundamental and the first two overtones. Right? So we should see very carefully here the key points given. Next, find wavelength in the fundamental and first two overtones. Right. First, see key points in the problem. Rope length is given. Mass also given. From these two, we can calculate mass per unit length. Right? Mu value. Next. Is fixed at one end, fixing one end, and is tied to a light string at the other end. See the meaning of this. Tied to a light string at the other end. That means other end is free to vibrate. It is not fixed. It is free to vibrate. That means now question is one end of a string is fixed, other end is free. Okay. Okay. Now tension is given. Tension given, and from these two we can calculate mu value. Then we can calculate speed of a transverse wave. Find the frequencies of fundamental and first two overtones and a corresponding wavelength. Okay, let's see how we solve this one. So question is now one end is fixed. One end is fixed. Take x equal to 0. Other end is free to vibrate. So first harmonic means only half loop, right? Only half loop. That is the first harmonic. Okay. And if you take first overtone, one complete loop and one half loop, complete loop and one half loop, first overtone. And if you take next one, two complete loops and one half loop, that is second overtone. This is known as a third harmonic, and this is known as a fifth harmonic, right? Okay, first I want to calculate here what is speed. What is speed? And see, we are given length equal to 2 meter, right? Mass is 80 gram and tension equal to 256 Newton, right? So speed equal to root of T by mu. Okay. Root of mu value how much? Mu equal to 80 gram, 80 10 power minus 3 kg. Length is now, okay. So this is now how much? 4 10 power minus 2. So here root of 256 by 4 10 power minus 2. Then see how much we get. So 4 here. How many times we can take 256? See calculation carefully. root of 256 by, it is given 80, mass is given 80 gram, right? And length is 2 meters, right? So 40 10 power minus 3, that is a 4 10 power minus 2. Okay, from this we are going to get now speed. So 4 here, how many times we get? 6 times, right? 6 4s 24, 16 4 and double zero. That means it is equal to 80 meter per second. That is now speed of transverse wave in the string, right? So now we have to calculate frequencies of the fundamental and first two overtones, right? Yeah, V equal to F into lambda. See, in first case, what is lambda value? Already we have discussed that lambda equal to, see how much it is. In first case, we can write lambda by 4 equal to, it is L. That is the first harmonic. From that, lambda equal to 4L, right? That means in first harmonic lambda value, it is 8 meter. Okay. So I'm taking this as V, sorry, it is V value 80. I'm taking this as F1. F1 into lambda value 8. So F1 equal to 10H. Okay. Now next one is a third harmonic. Third harmonic means frequency is now 3 times of the first harmonic. So 30H. And next one is a fifth harmonic. Frequency is 5 times of the first harmonic. Right. And once we have velocity and frequency, we can find a corresponding wavelengths, right? Directly by speed by frequency. Okay. So like this, we can solve the problem. Now see next problem. Right. And this question is taken from Irodov. Now see the problem. A plane harmonic wave with a frequency omega propagates at a velocity v in a direction forming angles alpha, beta, gamma with x, y, z axis. Find the phase difference between the oscillations at the points of medium with the coordinates x1, y1, z1 and x2, y2, z. Now see carefully here what are given. Plane harmonic wave. It is a plane harmonic wave. Frequency given, velocity given. Its direction is making angles alpha, beta, gamma with x, y, z axis. Find phase difference between the oscillations at the points of the medium. We are given 2 points. Okay. Their coordinates given. We have to find the phase difference. Right. See how we start the problem. So first of all, here energy propagating in three-dimensional space. So first writing equation y equal to, it is a plane wave. So A must be constant. A is sine. It is omega t minus k bar dot r bar plus phi. Students, earlier we have taken omega t minus kx plus phi when wave was propagating along positive x-axis, because in that energy propagation was confined to one direction, means one line, you can say x-axis. But now it is in three-dimensional space. It is now k bar dot r bar. Okay. And k bar is known as wave vector. What is k bar? K bar is known as a wave vector that can be taken as a kx I cap kyj cap plus kz k cap. Okay. And if you take modulus of k bar, that is equal to 2 pi by lambda, which we have learned earlier, known as a wave number, right? And modulus value is nothing but square root of kx square plus ky square plus kz square modulus value. Now we are given 2 points, R1 bar, R2 bar, right? And we are knowing that this entire one, omega t minus k bar dot r bar plus phi, entire one is known as a phase. Okay. Then phase difference will be. Now we are calculating at one instant. That means t fixed. So omega t, same for both. Phi value constant, same for both. Only changes now k bar dot r bar. Therefore, phase difference. Let us take phase difference as, write down here, phase difference is equal to what I am writing here, k bar dot, it is r1 bar minus r2 bar. See why I have taken like this means omega t same, phi value same, only changes for first one k bar dot r1 bar, second one k bar dot r2 bar, right? That's why phase difference equal to k bar dot r1 bar minus r2 bar, or we can take r2 bar minus r1 bar. Okay, because we are taking only difference, right? Right. Now see what we can write here. K bar. In the place of K bar, what we can do is, it is Kx. Kx means K cos alpha, K cos alpha I cap plus K cos beta J cap, because we are given direction of propagation makes angles alpha, beta, gamma, right? With x, y, z axis, which are known as direction cosines, cos alpha, cos beta, cos gamma, known as direction cosines, right? K cap dot dot R1 bar minus R2 bar. This is taken as x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap, z1 minus z2 k cap, right? Now see after calculation what we get. I'm taking k outside, so take k outside. Remaining is x1 minus x2 into cos alpha, because I cap dot I cap is 1, right? Next, y1 minus y2 into cos beta plus z1 minus z2 into cos gamma, right? That is now final result. But we are given here in terms of omega and speed, okay? So in the place of k, what we can write? In the place of k, we can write it is omega by v, right? We know omega v equal to omega by k. So k equal to omega by v. So this is now our final answer. I hope you got the clarity. Let us go for next problem. Right. Now this question also taken from Irodov. See the problem. A plane wave of frequency omega propagates so that a certain phase of oscillation moves along the x, y, z axis with velocities v1, v2, v3 respectively. Find the wave vector k bar, assuming the unit vectors ex, ey, ez of the coordinate axis to be assigned. So this is almost same as the previous problem. Frequency given, velocity components are given, and we have to find wave vector, right? Yeah, see carefully how we are solving the problem. We have to find k bar. K bar is equal to kx I cap plus ky j cap plus kz k cap, right? And we have learned that v equal to omega by k. That implies k equal to omega by v, right? When you want kx value, then kx equal to omega by vx. Okay. Ky value omega by vy and kz value omega by vz. So in our problem, vx given as v1, vy given as v2, vz given as v3. And in the place of I cap, j cap, k cap, they have taken ex cap, ey cap, ez cap. Okay. So just put these values in that one. Okay. So question is very simple one, right? Let us go for next problem. Right. A plane wave, a plane elastic wave, y equal to a cos omega t minus kx propagates in a medium k. Find the equation of this wave in a reference frame k dash moving in the positive x direction with a constant velocity v relative to the medium. So here we are changing the medium. So changing medium means changing origin. So here medium is, now you can see reference frame is moving. That means origin is also moving. See how we are starting the problem. Function is a cos omega t minus kx. How we are starting the problem. So function is given y equal to a cos omega t minus kx, right? This is now from ground frame. See what I'm saying here. Let us consider a spring, for example. And I'm taking this end as origin. Okay. And we are focusing one point somewhere here. And its position coordinate is x. I am repeating. Consider a string. Just for understanding a string. Take one end as origin and focus one point on that whose coordinate is x. Now we are observing same point. We are observing now same point from different frame, and that frame is moving along positive x-axis with a velocity v. This is taken as x-axis, right? Now in this frame, what happens is after some time t, the origin will be somewhere here. Let us take this is origin O, ground frame. This is now O dash, which has velocity v. So if you are taking time t, in time t, the origin O dash has moved a distance v into t. And with respect to this origin O dash, for same point, position coordinate is x dash. Let us take here like this. It is x dash is a coordinate of that point from this origin. I am repeating, we are giving one position coordinate with respect to O dash, that is x dash. And this origin has traveled a distance v into t in time t, right? Now from this what we can write? We can write x equal to x dash plus vt. I hope you are getting it. Just the diagram vt, right? From where to where? O to O dash distance vt. This is the distance traveled by that frame in time interval t. From this origin O dash, position vector of this point is x dash. So x equal to x dash plus vt. Now substitute this in equation 1, right? Y equal to a cos omega t. Okay, in the place of x, what I am writing is x dash plus vt. Okay. If you want to rearrange, we can write this as a cos omega t. I'm taking common 1 minus, see what else left, 1 minus kVt, right? 1 minus kVt. I'm taking by omega here, okay na? See carefully, minus kx dash. Right now this is going to become a cos omega t into 1 minus, in the place of k by v, see what we can write? Is v by small v. I am taking small v for speed of the wave, okay, into t. Okay, what I am taking here? In the place of omega by k, I am taking wave speed, that is small v, right? This is our result. Okay, so we are just replacing x with x dash plus v. So main thing here is understanding what is a problem given. Once we get a clarity, definitely we can solve the problem, right? Let us go for next problem. Right. So this question also taken from Irodov. See what is given. Find the radius vector defining the position of a point source of spherical waves if that source is known to be located on the straight line between the points with radius vectors r1 bar and r2 bar, at which the oscillation amplitudes of the particles of the medium are equal to A1 and A2. The damping of the wave is negligible. The medium is homogeneous. Now see in these key points, it is a point source. In case of point source, we have to focus amplitudes. They are proportional to 1 by r, or you can say inversely proportional to distance of those points from the source. We are given 2 points whose radius vectors are r1 bar and r2 bar and corresponding amplitudes, right? So we have to get radius vector defining the position of a point to source. And one more condition given, source is known to be located on the straight line between the points. Okay, it is between the points. Right. Let us see how we are going to start the problem. Right. First of all, make a diagram for the given condition. Given source is now in between those 2 points. Let us a point A and point B. There are 2 points, right? Let us take origin somewhere here. With respect to that origin, one is just this is right. With respect to that origin, position vector of this point, take it as it is R2 bar, and for this point, position vector is R1 bar, and position vector of the source, take that as R bar. Okay. And let us take distances between the source and points as x1 and x2. So we have learned that amplitude is proportional to 1 by r. I'm taking here 1 by x to avoid confusion. That implies a into x is a constant. What is that? A into x is a constant. So first starting point. For a point to source, amplitude proportional to 1 by distance. That means a into distance should be constant. Okay. So from this, what I can do is here, a1 x1 should be equal to a2 x2, right? How to get x1, right? How to get x1? This is now question, right? What we can do is, if you take a triangle, what you can take here, A, S, O. Okay, take the triangle. Let us take with respect to x, its a position vector is x1 bar, right? Okay. Then see what we can write. R1 bar minus x1 bar minus R bar equal to 0 bar, right? See carefully once. R1 bar minus x1 bar. Why minus means? We are moving opposite to direction of that vector. Minus x1 bar minus R bar. Again moving opposite to R bar, right? Therefore, R1 bar minus x1 bar minus R bar equal to 0 bar, right? From this, we can get x1 bar, right? In the same way, take triangle, OSB. Okay. So in this, what we can write? R bar. Let us take S2B, that is x2 bar. Okay. R bar plus x2 bar minus R2 bar equal to 0 bar. Okay. Now use x1 bar, x2 bar in the above equation. Take this equation as 1 in that equation 1. Now coming to here, A1. In the place of x1 bar, what I have write? It is R1 bar minus R1 bar minus R bar, right? That is equal to A2 into, see here I am writing minus x2 bar. What is x2 bar? It is R2 bar minus R1 bar, right? X2 bar is R2 bar minus R bar, right? And see why I have taken minus. Because R1 bar minus R bar. R1 bar minus R bar is left side direction part. R2 bar minus R bar is right side. That's why I have taken here minus. Okay. Right. Now simplify this. Remaining just simplification part. It is A1 R1 bar. Okay. Plus A2 R2 bar. I have taken that to left side. Okay. Equal to. I'm taking now R bar to right side. So R bar into A1 plus A1 plus A2. That means R bar equal to A1 bar, sorry, A1 R1 bar plus A2 R2 bar by A1 plus A2. Okay, this is our final answer. I hope you got that clarity, right?